Hey guys, we're here in the classroom and we're going to do this check our understanding. So in today's class we took some notes on these new trig functions and we're going to figure out if we can solve these 4 questions in regard to these 2 pictures. So it says in the diagram, triangle ABC, and then they put 1 squiggle. So it doesn't look like that's the congruent sign. In fact, this is the sign for similar, meaning one is the big and one is the small version of the other, similar. Okay, so they tell us that one is the big version and one is this little version. How can we use these trig ratios to solve for some of these missing information? All right, so it says, what is the ratio that defines the tangent of y? So if our reference angle is y, so if I shade that in and go opposite angle y, that would be opposite. And then if I go opposite the box, opposite the 90-degree angle is my hypotenuse. And the other side that hasn't gotten labeled yet, that would be my adjacent side. We notice that the tangent of angle y, in fact, the tangent of any angle is the ratio opposite over adjacent. And in fact, we have information to plug in. The opposite side of angle y is 5, and the adjacent side of angle y is 12. And so, in fact, that's all they're asking for part A. What is this ratio? The ratio is 5/12. Now let's look at part B. It says, what is the ratio that defines the tangent of angle B? So if we go over here to angle B, we notice this is this opposite side, and then opposite the box is going to be the hypotenuse, and then the side I haven't labeled yet is this adjacent side. Now it says, what is the tangent of B? Well, the tangent of angle B would have to be the opposite over the adjacent relative to that picture. And I usually start abbreviating eventually here. So the tangent of B is, I don't have anything to plug in, and I don't have anything to plug in, but do we have a way of knowing that angle Y and angle B are the same? Well, actually we do. Angle B and angle Y are listed at the same position in this triangle order, which means they have to actually be the same measurement. Now you might be wondering, like, how is that possible? Well, they're telling you they're the same. So this statement is basically saying, this is the mommy, this is the baby. So that means these angles would line up. And we could take a piece of patty paper and verify that. So let's go and get a piece of patty paper. All right, we've got a piece of patty paper. Is angle Y the same measurement as angle B? And it looks like, yes, it is. So whatever the tangent of Y would be should equal the tangent of B, so it has to be 5/12. And you might be thinking, well, wait, that's twice as big, so why would that make sense? Well, we're going to make sense of that here in just a minute. See which value is larger, the tangent of W or the tangent of A? Well, the tangent of W, let's just trace W here, and A are the same. Those angles are the same because A and W are both listed first. So those 2 angles are the same. So the tangent of W should equal the tangent of A. Now for most people, they're thinking, that doesn't make sense, Miss Kruzmark. Shouldn't this be bigger, right? The tangent is opposite over adjacent, and this opposite side looks much longer. But the other thing is this adjacent side also looks much longer. So let's play this out. We could do this a couple ways, but I think I know the hypotenuse, right? Because I can use a squared plus b squared is c squared. If the opposite side, one of the legs, is 5, and the adjacent side, the other leg, is 12, this is one of our Pythagorean triples. So we get c squared is equal to 169. So the square root of 169 is 13. So this is 13. So notice side AB, which is listed first and second, has to match side WY. They have to make the same ratio. So if WY is 13, and look, this one's 26, they doubled it. So this is the baby and that's the mom, and they doubled it. So this would then be, instead of 5, opposite the y, this would be 10. And the medium side, instead of 12, it would be 24. So if we go back in our math, we say to ourselves, oh, that's why the tangent of b was the same, because the tangent of b is opposite, 10, over adjacent, 24. And those are actually the same. We could verify that in a calculator. 10 divided by 24 is the decimal, 0.416 repeating. And 5 divided by 12 is the same decimal, 4 points. So notice it does make sense that they are equal. All right, so now does this make sense? The tangent of W is equal to the tangent of A. Well, let's look a little closer. The tangent of W, so now the tangent of W, this is my reference angle. So I kind of got to erase all of these labels because they were in reference to angle Y. Now that I'm working in reference to angle W, the opposite side of W is 12. The hypotenuse doesn't change when you change the reference angle, but now this is the adjacent side. So the tangent of W is the opposite side, 12, over the adjacent 5. Now when we look at A, angle A, same thing, these labels change because I'm going off of a different angle. If my reference angle were angle A, this would be the opposite, and this would be my adjacent if my reference angle was angle A. So the tangent of A is opposite, 24, adjacent, 10. Notice these each would be the same decimal as well. 12 divided by 5 is 2.4, and 24 divided by 10 is 2.4. So that's why we said they were equal to each other. Okay, now last question, it says, which value is larger, the tangent of W or the tangent of B? So we said the tangent of W is 2.4, right? And the tangent of B is 0.416 repeating. So which one's bigger? Looks like that one's bigger, right? The tangent of W is bigger than the tangent of B. All right? Well done, guys. See you next time.